Hello guys, so today we are going to talk about the one of the most important algorithms and the easiest algorithm, that is KNN, or K nearest neighbors. So this algorithm is basically, what it does is it divides the dataset into various parts, and as soon as the new data comes, it tries to find the minimum distance of its neighbors and tells that it is in which category. So it is basically using the methods like various distance algorithms, such as the Manhattan distance, Euclidean distance, or max distance. And using these algorithms only, it tells whether this is of category 1 or category 2. So it is like it can be said in an equation form like h of x is y of I, where all the possibilities of x, which can give me the resulted output, which is our expected output. Like in machine learning, we say that it's our train set and test set. So test set are my yi's. So using the all the hypotheses, we want to calculate the yi, or we want to calculate the test sets. So where h over here is set of all possibilities, so like set of all the possibilities which we can use, so that to get a correct output. So whenever we want to apply any algorithms or any test sets or any of the methods on any data, the first requirement is our data. Once we have data, we can apply any algorithms, or we can apply any our hypothesis or any formulas which we can invent. But before everything, we need data. So data comprises of whole sets, and we can't use whole sets. We can use, but we don't use, because we want to test our data, and so that our basic aim in the machine learning is to train the data in such a way that it should work tomorrow. So train today to work for the work of tomorrow. It's not like we should train it today and it work today. So for that purpose only, we divide data into various parts. So data can be divided into firstly into two parts. We say it as a train and test. So the test data is never shown to the our algorithms, and once our training is done, we show it to the algorithms and check over that if it's working correctly or not. But there are chances that in some cases that it works in a good manner, so it is called as overfitting. Like suppose we are having some data set where the train sets is having all the data, and as soon as we apply on the test set copies the data from the test set train set, and then that data is shown and we get the correct result. So that's why we don't apply it won't work every time. So in the next time, what we do data, we divide train data into two parts: the train data and the validate data. This validation data, what it does, we repeatedly do one thing, that we train the data and then validate it on, and then we apply it on the test set. But there are various times, like in some cases we get overfitting or underfitting. So like if we are having 1 1 1 1 in the train sets and 2 2 2 in the test set, so we will not get the resulted output or expected output even though our algorithms is correct, because in that case our algorithm don't know what to do with the 2 to 2. So for that to overcome all these situations only, we use the data so in three parts. So data will be divided into three parts, like train, test, and validate, and so it can work on our real lab data as well. So here is the standard KNN image, how it looks and how people represent it. So I am going to represent it in the same way, so that you can also understand. And this is how only the machines also understands, and it is how the machines also works. So it is better to show it here in the start only, so that you don't get confused in the future. So suppose we have two data, one in the red color, one in the blue color. So why I'm talking about two data, because I can't show you in the 3 dimensions over here. And another thing is the KNN works only on the categorical data. It won't works if the data is not categorized into X or Y types. If you are using lame or vague data, it will not work over there. So if the data is categorized, so there are 10 types of categories, but they should have a category. So that's why we are using KNN in that we are using it into two category of data. One is our red category, another is our blue category. So if our data, if what KNN does is it looks for the nearest neighbor. So if it looks for the nearest neighbor in the sense which is the nearest element to that. So if you see on the top we have a blue color, so that blue color data, if we use it by k is equal to 1, so k value is k is equal to 1 means the number of neighbors that we can see. So here we can see only one neighbor. So if we are using one neighbor, then it will say that yes, it's a red data, but actually it's a blue data. So if we use 2, then also we are getting red. If we have 3, 4, 5, so we are getting the red only, even though we are having the blue data set over there. That then also it is having the it is giving the result as a red data. Same way, if we are using in the last in the bottom, if you see there is a red dot, so that red will be categorized as blue. But if we see there is a violet on the line which is categorizing our data. So on that line, if we are using, if we use the middle one as a k is equal to 1, we will get the blue data. If we use k is equal to 2, then there is a tie. So there we don't use k as even values because there are chances of having a tie. So most of the time we use k as a odd value so that the chances of tie can be reduced. So if we used k as a 2, it is the chances of having as a tie, and we use 3, we see that it is a red data. So it depends upon the number of k. We can't use the k as a whole, because if you use it as a whole, so the data will not be categorized into any category, either blue or a red. If we divide the data into a k is equal to 1, so we will get a vague or useless output. So it is very important to decide what is the value of k. So here I was just it is just an introduction to KNN. In the next coming lectures, I will talk about how to code KNN and how to know the algorithms and all. So thank you for listening till here.